This is SpaceTime, Series 27, Episode 131, for broadcast on the 30th of October 2024. Coming up on SpaceTime, record energy gamma rays detected in the Milky Way's core, discovery of what could be the first triple black hole system, and problems for NASA as they try to test a new deployable solar array system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected ultra-high energy gamma rays being emitted from the centre of our galaxy, the Milky Way. The findings, reported in the Astrophysical Journal Letters, are giving astronomers a new look into a violent mystery in the galactic core. The observations were achieved using the high-altitude water Cherenkov, or Hawk Observatory, located 13,000 feet above sea level on Mexico's Sierra Negra volcano. Scientists measured the strength of the newly discovered gamma-ray source at more than 100 tera electron volts. That's an order of magnitude higher than ever seen before. The study's principal investigator, Pat Harding from the US Department of Energy's Los Alamos National Laboratory, says the new research is the first to confirm the Milky Way's galactic center ridge as an actual source, named a P-vatron for these high-energy gamma rays. Hawk Observatory has been gathering data for more than 7 years, during which time Harding and colleagues observed nearly 100 gamma-ray events with energies of more than 100 tera-electron volts. The observations have allowed cosmic ray interactions with the P-vatron to be directly studied, and therefore compared with other observations, helping to pin down the emission process and location. The actual P-vatron itself remains a not well understood phenomenon, but the fact of its existence, in whatever form it takes, points to the violent regime occurring in the galactic centre. Now, of course, this is the same region of the Milky Way known to contain Sagittarius A star, a galaxy's central supermassive black hole, which is surrounded by neutron stars and white dwarfs, which are stripping material from other nearby stars. Sagittarius A star itself has about 4.3 million times the mass of our Sun, and it's located some 27,000 light-years away. It's an area shrouded with dense gas clouds that can reach temperatures of more than 1 million degrees, and all this tends to prevent much direct optical observation of the region. So, the detection of gamma rays is proving to be crucial for illuminating the cosmic process at work in this extreme environment. Ultra-high energy gamma rays originate in the presence of a P-vatron source, and that accelerates the particles to 1,000,000 billion electron volts in energy. That's a quadrillion times more powerful than the photons coming out of your average light bulb. And the cosmic ray photons generated by the P-vatron are travelling at more than 99% the speed of light, interacting with dense ambient gas, which results in the ultra-high energy gamma rays. The energies involved point to some of the most violent processes conceivable in the universe. We're talking about things such as the death of stars in supernova explosions, the shocks and radiation that accompany fusion-rich starbirth, or a black hole swallowing up another black hole. Harding says that a lot of these processes are so rare, one wouldn't expect to see them happening within our galaxy, or alternatively, they don't occur on scales that correlate with the size of our galaxy. Hawk is a unique experiment, designed to capture the relatively few ultra-high energy gamma rays that can travel interstellar distances to reach the Earth. It comprises 300, well really they're grain silos that have been filled with water, and the bottom of each silo is lined with photomultiplier detectors. When ultra-high energy particles reach Earth's atmosphere, they break up into extensive air showers or cascades of lower energy particles. As the charged particles pass through the tanks of water at speeds outpacing the water's phase velocity, they produce Cherenkov radiation, which gives off a blue glow. It's an effect somewhat similar to an auditory sonic boom. The scientists then analyse the time distribution of the particles detected across the tanks in order to understand the energy regimes involved, finding the origins of the particles as ultra-high energy gamma rays. The Hawk Observatory was built on the groundbreaking Milky experiment. That's a gamma-ray observatory with a 5 million gallon water pond and 700 light detectors built just outside of Los Alamos. Milky took data through 2008, and then the researchers moved south to the Hawk Observatory to be able to capture particles closer to the galactic centre. The researchers now plan to extend the Hawke Observatory's findings, narrowing down the specific site of the Pave-Atron source with a new piece of equipment, the Southern Wide Field Gamma Ray Observatory. That's a facility being built in the Atacama High Deserts of Chile. With that wider window of view to the centre of the Milky Way, scientists may eventually come close to viewing the mystery at the very heart of our Milky Way galaxy. This is SpaceTime. Still to come, discovery of the first triple black hole system and problems for NASA's new deployable solar array demonstration flight. All that and more still to come on SpaceTime. Astronomers have discovered what may be the first triple black hole system. The newly discovered system, located some 8,000 light-years away, may be the first direct evidence of what astronomers refer to as gentle black hole formation. Many solar mass black holes detected so far appear to be binary systems, made up of two black holes, or a black hole and another star, circling each other. These spiral around each other, drawn together by the black hole's intense gravity to form a tight orbital pair. But now a surprising discovery is expanding the picture of black holes, the objects they can host, and the way they form. The new findings, reported in the journal Nature, involve what could be a black hole triple system, the first ever such discovery. Now, this new system consists of a central stellar mass black hole in the act of consuming what could be a small star that's spiraling very close to the black hole roughly every 6.5 Earth days. Now, that's a configuration similar to most binary systems. But surprisingly, a second star appears to be circling the black hole, although at a much greater distance. The study's authors estimate the far-off companions orbiting the black hole every 70,000 Earth years. Observations suggesting that the primary black hole seems to have a gravitational hold on an object so far away is raising questions about the origins of the black hole itself. See, stellar mass black holes are thought to have formed through the violent explosion of a dying star in a process known as a core collapse supernova. During this process, the star releases huge amounts of energy and light in a final burst before suddenly collapsing into an invisible black hole. This team's discovery, however, suggests that if the newly observed black hole resulted from a typical supernova event, the energy it would have released before it collapsed would have kicked away any loosely bound objects on its outskirts. So the second outer star shouldn't be hanging around. Now, we've seen examples of this before, where a star about to go supernova suddenly simply disappears. And it's disappeared because instead of exploding as a supernova, it's collapsed directly into itself, forming a black hole. And that's what scientists believe may have happened with this black hole in this three-part system. The black hole formed through a more gentle process of direct collapse, in which the star simply caves in on itself, forming a black hole without the dramatic last-minute flash. Such a gentle origin wouldn't disturb any loosely bound faraway objects. Because the new triple system includes a very far-off star, it suggests the system's primary black hole was born through this gentler direct collapse. The discovery of this triple black hole system has come almost by chance. The authors had been looking within the Milky Way galaxy for signs of new black holes. Out of curiosity, they reviewed an image of V404 Cygni. That's a black hole about 8,000 light-years away. That was one of the very first objects ever confirmed to be a stellar mass black hole. That was back in 1992. Since then, V404 Cygni has become one of the most well-studied black holes in astronomy. It's been documented in over 1,300 scientific papers. However, as this team studied images of V404 Cygni, they noticed what appeared to be two blobs of light, surprisingly close to each other. Now, the first blob was what others had already determined to be the black hole and an inner closely orbiting star. The star is so close that it's shedding some of its material onto the black hole, giving off light. The second blob of light, however, was something scientists didn't investigate closely until now. And that second light is most likely coming from a far-off star. One of the study's authors, Kevin Burridge, says the fact that we can see these two separate stars over such a great distance actually means that the stars have got to be fairly far apart. He calculated that this newly discovered outer star was around 3,500 astronomical units away from the black hole. Now, an astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. So in other words, this outer star would be around 100 times further away from the primary black hole than what Pluto is from the Sun. And of course that raises another question, whether or not this outer star was actually linked to the black hole in the inner star. To find out, the authors examined data from the European Space Agency's Gaia spacecraft, which tracks the motion of stars as they orbit the galaxy. They then analysed the motions of the inner and outer stars over the last 10 years of Gaia data, and they found that these two stars moved exactly in tandem compared to other neighbouring stars. That means they're most likely in the same system. So, how exactly could this system have formed? Well, if the black hole arose from a typical supernova, the violent explosion would have kicked away the outer star long ago. However, simulations showed that the easiest way to make the triple system work was through a direct collapse. In addition to giving clues about the black hole's origins, the outer stars also reveal the system's age. That's because the star happens to be in the process of becoming a red giant. That's a phase that occurs at the end of a star's life. Now, based on this stellar transition, the authors determined that the outer star is about 4 billion years old. Now, given that neighbouring stars are all born around the same time, it suggests the entire system is also 4 billion years old. This is SpaceTime. Still to come, problems with the new NASA experimental solar array system, and later in the science report, a new study shows that standing compared with sitting doesn't improve cardiovascular health after all. All that and more still to come on SpaceTime. NASA has run into problems as it tries to deploy a new combined solar array and antenna system aboard its Pathfinder technology demonstrator for spacecraft. It seems the array's boom is bent and therefore not extending properly. The 12-kilogram spacecraft is a 6-unit CubeSat demonstration mission. It's designed to test the new lightweight integrated solar array and antenna, a very high-power, low-volume deployable combination antenna and solar array. The 4-petal solar array system, or LISA-T, is a thin-film solar array that offers low mass, lower stored volume, and 3 times more power per mass and volume allocation than current solar arrays. The new technology will eventually enable future deep space missions to acquire and communicate data through improved power generation and communications capabilities, all on the same integrated array. The spacecraft was launched aboard a Falcon 9 rocket from the Vandenberg Space Force Base in California as part of SpaceX's Transporter 11 mission. Once in orbit, NASA evaluated initial flight data and imagery, confirming the spacecraft systems, including its onboard electronics and payload support systems, were all operating nominally. The deployable integrated antenna and solar array comprises 4 foldable petals and an extendable boom, which are all stored for launch, taking up no more space than a coffee mug. Once in orbit, the spring-loaded boom is released. It's designed to extend out about a metre. The 4 petals, which are folded and attached to the boom, would then be cleared to be released, expanding out to create a 2-metre wide array using shape memory alloys. However, on this test flight, it looks like the central boom has failed to fully extend. That prevents the petals from unfolding and generating power or providing communications operations. John Carr, the Deputy Chief Technologist at NASA's Marshall Space Flight Center in Huntsville, Alabama, says once the technology is proven, the new thin film arrays will vastly improve power generation and communications capabilities for many mission applications.
LISA-T stands for the Lightweight Integrated Solar Array and Antenna. It's a super compact, stowable, thin-film solar array that, when fully deployed in space, offers both a power generation and communication capability for small spacecraft. LISA-T provides significantly more electrical power generation per unit mass and per unit volume to enable higher capability Earth-orbiting small spacecraft, as well as for small spacecraft to travel deeper into space than currently possible. LISA-T was developed at NASA's Marshall Space Flight Center in Huntsville, Alabama, and is a flight project with the Pathfinder Technology Demonstration Program, which is managed out of the Ames Research Center in Moffett Field, California. Several commercial partners played a key role in developing LISA-T, including Nexolve Holding, Terran Orbital, Ascent Solar, and Microlink Devices. The importance of the LISA-T technology cannot be understated. Small spacecraft are becoming increasingly important to NASA's deep space science and exploration goals. The challenge we often see with small spacecraft is they tend to have very little mass and volume to spare. If we want to do more with these missions and send smaller spacecraft further into space, we need to provide them with access to more power without requiring a large amount of mass and volume. But how do you do that when space and mass is at a premium? LISA-T meets this challenge with its thin-film solar array, which offers 300% more power per mass and volume than current state-of-the-art thick-film solar arrays. The spacecraft prepares LISA-T for deployment and begins by firing the first burn mechanism to cut tie-down cords and release the central booms. These booms passively deploy via stored kinetic energy. With this process, the solar arrays are pushed away from LISA-T's main structure, giving it room to expand. A second burn mechanism is then activated to release each of the 4 solar panels, which are tightly folded atop these central booms. These panels are then actively unfolded by a shape memory alloy that is embedded on the back of the panels. After completely unfolding, the panels lock themselves into place and maintain their shape and structure for the duration of the mission.
That's John Carr, the Deputy Chief Technologist at NASA's Marshall Space Flight Center in Huntsville, Alabama. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that standing more compared to sitting really doesn't improve cardiovascular health after all. The findings, reported in the International Journal of Epidemiology, come despite the growing popularity of so-called standing desks in offices. They're used by people looking to offset the harms of a sedentary lifestyle caused by spending long days sitting in front of a computer screen. However, scientists at the University of Sydney have shown that over the long term, standing more compared with sitting doesn't improve cardiovascular health such as coronary heart disease, stroke or heart failure. And in fact, it could increase the risk of circulatory issues related to standing, such as varicose veins and deep vein thrombosis. Paleontologists have described the fossilized skull of an extinct giant elephant discovered in northern India's Kashmir Valley in the year 2000. The new research, reported in the journal Vertebrate Paleontology, sheds fresh light on a poorly understood episode of elephant evolutionary history. The skull was buried with some 87 stone tools used by prehistoric humans. Scientists say that from the general shape of the skull, the elephant belonged to Paleoloxodon, a straight-tusked family of elephants, which are among the largest land mammals that ever lived. Fully grown, adults could easily stand around 4 meters tall at the shoulder and weighed up to 10 tons. Now, by comparison, a modern-day Asian elephant weighs about 6 tons, and their African counterparts about 7. However, this Kashmir skull lacks a thick and forward-projecting crest at the skull roof, which typifies other Paleoloxodon skulls found in India. Scientists had speculated that the skull crest in these extinct elephants became more prominent with developmental and sexual maturity. But from the size, the wisdom teeth and a few other telltale features of the skull, it was evident that this animal was already a majestic bull elephant at the prime of its life. So the lack of a well-developed skull crest means this must have been a new and different species. A new study has found that artificial intelligence-assisted colonoscopies increase polyp and edema detection in routine screening. The findings, reported in the Journal of the Annals of Internal Medicine, follows a systematic review of randomized clinical trials comparing AI-assisted colonoscopies and conventional examinations. They found that AI-assisted colonoscopies found more polyps and precancerous growths in the colon than conventional examinations. However, the difference was only marginal, no better than the conventional method of finding serious growths per colonoscopy. Apple have released their first artificial intelligence update. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
It will be arriving on iPhones, iPads and Mac. This will introduce the first tranche of Apple's intelligence update. This is the first set of their features, the personal intelligence system protecting your data, privacy and AI. And Apple has been very strong on privacy, and they'd like to ensure that people think that they're going to be just as careful with your data in the world of AI compared with OpenAI or Google or Facebook, where privacy is something they feel they have access to your data and they can sell it. So we're yet to see if that strategy is going to work for Apple as it has in the past. I know that there'll be 18.2, the next update, the next version of Apple's intelligence that will come in December. And then we will see the image playground. You'll be able to create images just by typing in text or removing people by drawing a circle around items that you don't want on a page, which is copying things we've seen from Samsung and Google for some time. So Apple's playing some catch-up. There's no question that they're behind the times. And Tim Cook, the CEO of Apple, did a big interview in the last week where he acknowledged that Apple can be late sometimes, but they like to think that they get it right and do it in the most private and secure way. So the AI wars have barely just begun. 2025 will see a huge battle for the hearts, minds, wallets and usage of everyday people around the world wanting benefits from AI.
That's Alex Zaharov-Reutt from techadvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.